Hello everyone, my name is Samantha, and in this section of the presentation you will learn about energy and how it moves. Later on, Taylor will take over and show you all how to build a marble roller coaster. Looking at the picture on the left, we can see energy in so many ways. We can see lights on in the buildings, fireworks exploding in the sky, and an amusement park ride in motion. By the end of this presentation, you will understand what energy is and how it works. Once you understand energy, you can apply this newfound knowledge in building a successful marble roller coaster like the one imaged here. Firstly, when you are on a swing, do you know why it moves? When you want to go down a slide, do you know why you have to climb up to the top? The answer to both these questions is energy. Did you know that energy is more than what powers your lights? In fact, energy actually surrounds us. Our everyday lives are filled with energy. So what is it? Energy, in part, is what makes all things move in the world. From moving the imaged Ferris wheel on the left to being what moves humans, energy is behind it all. But how does energy work? In the image on the right, why does the ball move downwards onto the racket? This can be answered in part by gravitational force. One way in which energy leads to movement is through gravitational force. Gravitational force pulls all objects back down to the ground. When we throw leaves in the air or toss a ball, the reason they end up falling back down to the ground is because of this force. Gravitational force also acts on us personally, as could be seen by the fact that when we jump, we do not keep going up into the sky. We also drop back down. In this example, a book is on the top ledge of a bookshelf. Part of the book is on the shelf and the other part is dangling off the edge. Instead of staying like this forever, the book falls. The book falls because of gravitational forces pushing down on the book. Another important aspect of understanding energy is through energy transfer. Energy transfer is the transferring of energy back and forth between potential and kinetic energy. Potential energy is the energy that an object has the potential to release. The potential energy of an object is based on where it is and what it is. For example, a balloon that is filled with lots of air has a lot of potential energy, as the air in the balloon can be released. Meanwhile, kinetic energy is when the object releases the energy and is actually in motion. For example, when a balloon is deflating and releasing all of its air, it is using kinetic energy. Here is an example of potential and kinetic energy. This is the same bookshelf we used to learn about gravitational force. In this example, we can see that when the book is teetering on the edge, that this is potential energy. This is because the book has the potential to fall. In the second image, we can see that kinetic energy is the actual movement of the book as it falls. Gravitational force plays a part in this image, as it is what is causing the book to fall in the first place. Gravitational force, potential energy, and kinetic energy occur together. As another example of this relationship, we can see a cat on a string. The kitty and the dog would like to high five, but the kitty would need to move over a huge distance to get to the floating puppy. The kitty's not straight on the rope. Instead of being pulled by gravitational force straight down, the kitty is pulled upwards into the side by the rope. The potential energy in this situation is the kitty being held by the rope. If the kitty were freed from the rope, what do you think would happen? Let's snip the string. When the rope is cut, kitty is able to be pulled back down to the ground by gravitational force. At the same time, the potential energy from the kitty being held by the string is released, and the kitty swings across to high-five the puppy. This motion of swinging is kinetic energy. Now, something else important to our conversation on energy transfer is the concept of friction. Friction is a force that pushes in the opposite direction of motion. To say this more simply, friction slows down moving objects. Friction occurs when two things rub up against each other. For example, if you roll your pencil right now across your desk, you will see friction. The pencil and the table are rubbing against each other. Friction forces your pencil to slow down. A clearer image of friction can be seen in the image below. In this image, the woman kicks the ball, and the ball rolls with lots of energy. As the ball rolls further away, the energy becomes weakened as friction increases. As seen in the image, the ball stops before it can reach the goal. When you roll a ball across a room, the reason the ball stops moving at some point is because friction between the floor and the ball slows the ball down. It is important to remember that friction is weaker when surfaces are smooth and stronger when surfaces are rough. See how the girl is kicking the ball in grass? Grass is not smooth, but the ball is. What do you think would happen if the girl kicked the same ball on concrete? So, looking at the two types of balls in this image, which do you think would roll further? The pom-poms or the marble? Why? Looking between the two types of flooring, which do you think would be better for rolling a ball on? Wood or carpet? Pause the video if you would like to answer. Okay. So the answer to these questions are the marble and wood. They're both smooth, leading to less friction. Here's a fun fact. Did you know that there's no friction in space? What do you think would happen if we rolled a ball in space? According to Newton's third law of motion, something at rest or in motion will remain at rest or in motion unless an outside force acts on it. Simply put, things will not begin moving or stop moving unless something outside of the object interacts with it. For example, a ball will not start rolling without you pushing it. Another example is that a ball will not stop rolling unless friction slows it down. Returning to our fun fact about there being no friction in space, what do you think happens to the ball rolling in space? Given that there's no friction when we roll the ball will forever move and never stop. Let's try to apply what we've learned about potential and kinetic energy. In this demonstration, you will need a piece of string and a paper clip. Pause this video if you would like a moment to get these items. Okay, so to start, tie the string onto the paper clip as can be seen in the second image. Now look at image 3. Grab the string end with one hand and hold it in front of you. Next, with your empty hand, grab the paper clip and pull it to your side while keeping the hand that is holding the string still, which can be seen in image 4. Finally, let go of the paper clip. What happens with the string? It swings. Try holding the paper clip at varying heights and watch it swing. Where must you hold the paper clip to make it swing higher? Where must you hold the paper clip to make it barely swing? Why does this happen? The answer to this is potential and kinetic energy. The greater the potential energy, the greater the kinetic energy. When you hold the paperclip higher, you increase potential energy. Now, let's try another little project, and while you do it, try to apply the things you have learned from this video so far. In this demonstration, all you will need is a marble and your desk. Please pause to grab your marble. What you will do is stand up next to your desk and hold a marble a couple inches above the desk and let go. Please pause to do this. Okay, so what happened to the marble? It drops down. How high did the marble bounce? It barely bounced, right? Now, following the images below, try holding your hand straight in front of you like the woman here is doing. Your hand should be in line with your shoulder. If you release the marble from this height, what happens? The marble bounces a lot more. Now, try sticking your hand out so that it is above your head and then release the marble just like this image of the boy shows. What happens to the marble? Yes, it bounces higher than it did before. Now, what have you learned so far that you could use to explain this demonstration? Why does the marble drop when we let it go? Pause if you'd like to try to answer. The marble drops because of gravitational force. Do you know why the higher we hold the marble, the higher it bounces? This is because the higher we hold the marble, the greater its potential energy is. We have now concluded this section, and Taylor will now take over.
The materials needed for the project include a roll of masking tape, one plastic cup, one marble, and your choice of tubing for the roller coaster. I chose 25 feet of plastic tubing. For the first step, you will need to tape the tubing to a high point on the wall. For step 2, you will need to make loops with the tubing and then tape them to a low point on the wall. For step 3, you will need to place the cup at the other end of the tubing to catch the marble as it comes out the other end. For step 4, you will drop the marble from the high point of the tubing. And if all goes well, the marble should end up in the cup. So what happened there? Before the marble was dropped, the marble had a lot of potential energy. Once the marble was dropped, the marble started to gain a lot of kinetic energy due to gravity. That same gravity started to work against the marble once the marble started going up the loop. When the marble went back down the loop, it gained a little bit more kinetic energy with the gravity. The same thing happens with the lower loop too. Once the marble is through the lower loop, it will begin to slowly lose kinetic energy due to friction. If there is enough kinetic energy to overcome the friction, it will end up in the cup. Design, build, test, and refine. Different marble materials could include a wooden ball, BB pellets, and pom-poms. Different tubing could include a pool noodle cut in half lengthwise. You could also use a timer to find out the speed difference on each different material. Design-wise, you could add more loops, or add a hill that goes into an inverse loop, or combine roller coasters with other groups. Here is a simpler explanation of kinetic and potential energy. The ball has a lot of potential energy before it is dropped. Once it is dropped, it begins to roll down the hill and gain kinetic energy. At the bottom of the hill, it begins to roll against the grass and slowly starts to stop due to friction from the grass. Our entire world is reliant on energy playing a huge part in all aspects of our lives, from eating to playing to us actually moving. When wanting to go on a slide, why must you climb up so high? When you sit at the top of a slide, what makes it so you can slide down? How come when we sit on the floor, we don't also slide? While involved in sliding and daily movements, energy is also the reason we have electricity, fueling our toys, shower, television, and lights.